Good day, everyone. I welcome you to this pre-recorded lecture. For today's topic, we will discuss the computed tomography imaging system. Our objectives for today are the following. So at the end of the lecture, you shall be able to identify the parts of a computed tomography imaging system. We shall also discuss the function of the parts of CT imaging system and the related uh, CT system components to their function. So the imaging system design of the computed tomography includes the three major components of a CT imaging system, which are the operating console, the computer, and the gantry. And each of these major components has several subsystems. The first, the first major component is the operating console. The CT imaging systems can be equipped with two or three consoles. So these these consoles are for has three. So the first console are used by the city radiologic technologist to operate the imaging system. The second console is for post-processing of images like filming or for filing. And this operating console also contains meters and controls, which are for the selection of proper imaging technique factors and for proper mechanical movement of the gantry and the couch, and lastly, for the use of computer commands. So a typical operating console contains controls and monitors for the various technique factors. So the operation of a CT scan machine or CT imaging system is not less than 120, it is usually not less than 120 kVp. The maximum MA is 400, but this varies during imaging according to the patient thickness to achieve minimal patient radiation dose. So this MA is adjusted by the radiologic technologist, of course. And also, there is also adjustable tissue slice, tissue slice thickness, which is normally in between 0.5 to 5 mm. So the slice thickness is selected from the console by adjustment of the automatic collimator by selection of various rows of the detector assembly. So later on, we will discuss the collimators also. To continue, there are also controls that are provided for automatic movement and for indexing of the patient support couch. And this control allows the operator to program for Z-axis location, tissue volume, the tissue volume to be imaged, and the spatial pitch. And also, the operating console usually includes two monitors. So the two monitors, these two monitors are the ones that we can see present in the CT scan room itself. So the first monitor is provided for the operator to annotate patient data on the image or what we call as encoding of data. So such data are the following, like the hospital identification of the patient, the name of the patient number, the age, and the gender. And the second monitor, and also it's not the first monitor is not just to annotate patient or to provide the basic details of the patient, but also this is also to provide identification for each image that we will acquire, like the image number, the technique that was used, like the KVP and the MA, and also the position of the couch. And while the second monitor allows the operator to view the resulting image. So, this second monitor allows the operator to view the resulting image before transferring it to hard copy or the physician's viewing console. So if the first monitor is usually for the basic function, the second monitor is to or usually for post-processing of images. So speaking of the physician's viewing console, this is also known as the physician's workstation. So this is the third console or the third monitor that is provided in a CT imaging system. So this physician's workstation is a console that allows the physician to call up or retrieve any previous image and manipulate that image to optimize diagnostic information. So this monitor is basically for the physician and to assist them in interpreting the acquired images. And if there were previous studies that they could check to compare the present acquired image, they could easily compare that. Also, the manipulative controls provided in the physician's workstation are the following. For contrast and brightness adjustment, there is also magnification techniques and region of interest or ROI viewing. And also, there is also use of online computer software packages. And these software may include programs designed to generate plots of CP numbers, computation of mean and standard deviations of CP values in an ROI, subtraction techniques for angiogram, for example, planar and volumetric quantities, and also for reconstruction of images like coronal view, sagittal view, and oblique planes. So, and this workstation or this console is usually remote from the CT wait or from the CT scan room. So this is usually located at the reading room or where the radiologist interpret images. So this console can be also used for post-processing tasks for all digital images, and this workstation is also linked to a picture archiving and communication systems, or also known as PACS network. Now let's proceed to the second major component of the CT imaging system. So the computer is a unique subsystem of the CT imaging system. So a large computing capacity is required because The computer must solve 250,000 equations simultaneously, depending on the image format. So imagine. So at the heart of the computer used in city, these two are present, the microprocessor and the primary memory. So we should know that the efficiency of an examination is influenced greatly by the reconstruction time, especially when a large number of slices are involved. So what is reconstruction time? So reconstruction time is the time from the end of imaging to appearance of the image. And many imaging systems use an array processor instead of a microprocessor for image reconstruction. Why? Why do they prefer array processor instead of microprocessor? This is because the array processor does many calculations simultaneously, and therefore array processor is faster than the microprocessor. So as simple as that. So they prefer array processor above the microprocessor because it is faster. The third major component of a CT imaging system is the gantry. So the gantry includes the following: the X-ray tube, the detector array, the high voltage generator, the patient support couch, and the mechanical support. So these subsystems receive electronic commands from the operating console and transmit data to the computer for image production and post-processing tasks. Now we will discuss one by one these subsystems of the gantry. The first one is the X-ray tube. So the X-ray tubes in current CT systems like multi-slice spiral CT have special requirements, and these systems, like the spiral CT, places considerable thermal demand on the X-ray tube. So the X-ray tube can be energized up to 60 seconds continuously. Therefore, high-speed rotors best are used in most for the best heat dissipation. So, since always man or palaging ginagamit or matagal na ginagamit ang X-ray tube sa CT scan as compared sa conventional X-ray, so the X-ray tube um, should have high heat capacity. And one way to achieve that is to have high-speed rotors, because X-ray tube failure is a principal cause of CT imaging system malfunction. So it has to be, X-ray tube has to be durable, or dapat kailangan tatagal talaga siya. So, so focal spot size. So focal spot size is also important in most designs. So city imaging systems designed for, we know that the city imaging systems are designed for high spatial resolution, right? Therefore, they incorporate X-ray tubes with a small focal spot. Ang ginagamit sa X-ray tube ng CT is small focal spot because they because this imaging, the computed tomography imaging, requires high resolution or high spatial resolution. Okay. So X-ray tubes also are very large as compared to the conventional X-ray tube. The X-ray tube of CT is larger or bigger. In fact, they usually have an anode heat storage capacity of 8 mega heat units or more. And also they have anode cooling rates of approximately 1 mega heat units per minute. So very fast cooling rate ng anode. And because the anode disk has a larger diameter and it is thicker, this results in much greater mass or mas mabigat. Yan. Let's discuss naman the limiting characteristics of the X-ray tube. So first is the focal spot design, wherein the small focal spot must be specially robust in design, so it should be durable. And focal spot cooling algorithms are designed to so um, innovations have improved the imaging system as time goes by. So therefore, there were um, focal spot cooling algorithms. Um, the focal spot cooling algorithms happened. So the purpose of this is to predict the focal spot thermostate, and when the thermostate is detected, the MA setting can be adjusted accordingly. And lastly, the heat dissipation. And an X-ray tube also is expected, so the life expectancy of an X-ray tube is for at least 50,000 exposures. Mm. The second subsystem of the gantry is the detector array or the detector arrays. So imagine a multi-slice spiral city systems have multiple detectors in an array. It could number up to 10,000. So previously, gas-filled detectors were used. So, and now, now all are scintillation solid-state detectors. So let's get to know the first detector used in city. So these are gas-filled detectors. This is also known as xenon gas detectors or xenon detectors. So when the X-ray beam interacts with the xenon gas, the gas the gas is ionized, and the electrons produced then travel and accumulate at the anode. This is then transmitted into an electrical signal which is sent to a computer system. So although this type of detector is relatively inexpensive or it's cheaper, it has a low quantum detection efficiency. So what is low quantum detection efficiency? This this refers to the proportion of X-ray photons that are absorbed by the detector. So therefore, if it has low quantum detection efficiency, this means that only a small proportion of the X-ray photons that pass through the body are actually absorbed by the xenon detectors, when in fact it could only absorb 60 to 70% of the X-ray photons. For this reason, xenon detectors are no longer used in modern day CT scanners. So what are the possible effects of this small or low quantum detection efficiency? Well, if there is only 60 to 70% absorbed X-ray photons that pass through the patient, this could this would require higher this might require higher radiation dose for the patient. So that is why this these detectors are no longer used today. So also, early scintillation detector arrays contained scintillation crystal. So the first one was photomultiplier tube assemblies. After the xenon detectors, photomultiplier tube assemblies was developed. So this type of detectors could not be packed very tightly together, and they required a power supply for each photomultiplier tube. So this is okay because as this is better than the xenon detectors, but this photomultiplier tube cannot be packed very tightly together because imagine you a usual spiral city has 10 up to 10,000 detectors, right? So they the system or the imaging system could not accommodate that that amount or that quantity if they will use the photomultiplier tube. And this type of detectors requires also power supply or constant power supply. Yun. That is why eventually they have been replaced with scintillation crystal photodiode assemblies. Scintillation crystal photodiode assemblies. So these type of detectors, the photodiodes convert light into electronic signal. So ang good thing nito, they are smaller and cheaper, and they do not require power supply. Yan. And ngayon, naging happy na sila sa scintillation crystal photodiode assemblies. So dito naman sila ngayon focus in improving or choosing the best crystal to be used. So the first crystal used in earlier times was the sodium iodide or NaI. And the sodium iodide was quickly replaced by bismuth germanate and cesium iodide. But now, the current crystals of choice and the usually present in the current city imaging systems are the cadmium tungstate and other special ceramics. This is now the crystal of choice. Okay, so the concentration of scintillation detectors is an important characteristic of a city imaging system because it affects the spatial resolution of the system. Now, ano ang maganda dito sa scintillation detectors? Scintillation detectors have high X-ray detection efficiency. In fact, approximately 90% of the X-rays that hit the detector are absorbed, and this contributes to the output signal. So if you now compare it to Xenon detectors, wherein they could only absorb 60 to 70% of the photons, X-ray photons. Now it was improved to 90% by using the scintillation detectors. And also, the efficiency of the X-ray detector array reduces patient dose. That's very important. It also allows faster imaging time and improves image quality by increasing signal-to-noise ratio. Therefore, detector array design is crucial in multi-slice spirality. So, ganyan ka-importante ang detectors. Now, let's discuss the third subsystem of the gantry, the collimation. So proper collimation reduces patient dose by restricting the volume of tissue irradiated. So that's how the collimation helps or reduces the patient dose by restricting the volume of tissue irradiated. And even more important is that it improves image contrast by limiting scatter radiation. And while in conventional radiography, only one collimator is mounted on the X-ray tube housing, while in the multi-slice spiroscopy, usually there are two collimators used. These are the pre-patient collimation and the pre-detector collimation. In the word itself, pre-patient, so this is present before the patient, and the second collimation is the pre-detector. This is present before the detector. Now let's know the difference between the two types of collimators. So pre-patient collimation is the first one. So this is mounted on the X-ray tube housing or somewhere adjacent to the X-ray tube housing. So this collimator limits the area of the patient that intercepts the useful beam. Therefore, this determines the patient dose. So the pre-patient collimator usually consists of several sections, so a nearly parallel X-ray beam results. So this collimation or collimator determines the patient dose. Remember that. Okay, now let's proceed to the second collimator, the pre-detector collimator or pre-detector collimation. So this restricts the X-ray beam viewed by the detector array. So this collimator reduces the scatter radiation incident on the detector array. So when properly coupled with the pre-patient collimator, this defines the slice thickness, which is also called the sensitivity profile. So again, the when the pre-detector collimation defines the slice thickness, which is also known or called as the sensitivity profile. So the pre-detector collimator reduces the scatter radiation that reaches the detector array. Therefore, this also improves the image contrast, and the pre-detector collimator determines sensitivity profile and slice thickness and improves image contrast by reducing the scatter radiation that reaches the detector array. The fourth subsystem is the high voltage generator. A high frequency generator is small because the high voltage step-up transformer is small, so it can be mounted on the rotating gantry. And so this is relatively small because it has to be mounted in the rotating gantry. And in properly designed multi-slice spiral city imaging system, the two should be matched to maximum capacity. So approximately 50 kilowatts kilowatt power is necessary for the gantry operation. The fifth subsystem is the patient positioning and the patient couch. So aside from the comfort provided to the patient, it must be also constructed. These patient couch or support couch should also be constructed of low Z material such as carbon fiber, carbon fiber. So why carbon fiber? Carbon fiber is the material of choice because it does not interfere with the X-ray beam transmission and patient imaging. Yeah, so the patient couch should also be smoothly and accurately motor driven to allow precise patient positioning that is unaffected by the weight of the patient. Regardless of the weight of the patient, the the table should move smoothly and accurately. So when patient couch positioning is not exact, what will happen? So the same tissue can be imaged twice. Therefore, this will double the dose or it can be missed altogether. The patient couch is also indexed automatically, so the operator does not have to enter the examination room between imaging sequences. So during the examination, the table or the patient couch automatically moves in and out of the gantry depending on the imaging sequence. So this feature reduces examination time required for each patient because there will be no need, the rad tech needs not to enter the room to adjust or move the table itself, right? Okay, the slip ring technology. So slip rings are electromechanical devices that conduct electricity and electrical signals through rings and brushes from a rotating surface onto a fixed surface. So one surface of the slip ring technology is the smooth ring, and the other a ring with brushes that sweep the smooth ring. So in a slip ring gantry system, power and electrical signals are transmitted through the stationary rings within the gantry. Therefore, this eliminates the need for electrical cables and making continuous rotation possible. So brushes that transmit power to the gantry components glide in contact grooves on the stationary slip ring. And also, composite brushes made of conductive material are used as a sliding contact. So an example of a material usually used as a brush is the silver graphite alloy. And the spiral city is made possible by the use of slip ring technology. This also allows the gantry to rotate continuously without interruption or without the use of cables. So thank you for your time, and I hope you've learned something, and take care. Bye.